Hello, good morning, good afternoon, good evening, depending on where you are in the world. Thank you for joining us for the latest in our series of webinars. This one's called Mastering Gantry Systems from Design through to Application. My name's David Weston, this is Alec Dick. Good morning, Alec.
Yeah, thank you, David, and thank you once again for you guys for joining us today. It's a really exciting presentation we've got showing you the latest development of our HDS Gantry system, which I think is fair to say more of a revolutionary development than evolutionary. So glad to be showing this. But as always, this is going to be an interactive event, so we welcome your questions either at the bottom or top of your screen, depending on whether you're on PC or mobile. You will find a Q&A button. If you hit that, you should be able to drop a question in there. You can do that at any point, and at the end of the presentation, David and I will do our very best to answer your questions.
That we will. Right, we've given ourselves 30 minutes to talk about a pretty big subject, so let's get stuck straight into the history, shall we? We have a long, proven, successful history of supplying gantry systems to various industries and hundreds of different types of applications. One of the primary reasons for that is the overall success in terms of features and benefits of our V system, Alec.
Yeah, so like you say, we've been doing gantry systems for decades now, and it's been built on our successful heavy duty and HDS2 products, a combination of sort of components that we put together, beams, slides, bearings, carriages. We've been able to provide multi-axis systems. But as you say, it's all based on V-guide technology, which is the core of our technology of many of our products.
For good reason.
Absolutely. And it does provide a lot of inherent benefits to gantry systems. You've got to think about these things being 3, 4, 5 meters up in the air. You want it to be reliable. You want it to be low maintenance. You need performance, speed, acceleration, accuracy, repeatability.
Precision.
Anything else?
Absolutely right.
Yeah.
Well, again, in terms of the major axes on a gantry system, the value of a V system is you can there is no limitation to what that major axis can be, because the compliance in a V system and the ability to match rails into much longer lengths. So there's a very, very compliant system in very many different ways, and like you say, 4 or 5 meters up in the air, you don't want to be up there too many times. You need it to be durable, you need to be able to fit it and forget it, and so forth. And the V system provides that, and that's one of the core reasons for our success in this type of industry in the past.
Yeah, absolutely. You don't want Fred going up his stepladder too many times to grease those bearing blocks, for example.
No, we don't. No, absolutely. Yeah. Right, so Alec, we know about robots that pick and place and stack and do all sorts of things, and we know about industrial cranes. From your perspective, where do you think HDS fits in?
Yeah, well, industrial robots are incredibly important in industry. We see them everywhere, all sorts of applications, all sorts of industries, and they are very good at what they do, and that is handling product, but within a given footprint. So you may have an industrial robot that is, handling 50 kilograms of payload within a 500 millimeter radius, but if you were to do the same payload, but within a 3 or 4 meter radius, then you're looking at a much bigger robot.
A much bigger robot, exponentially bigger price, I'm guessing. Yeah, it's they do. When they get big, they get expensive.
Exactly. But what I'm saying is that a gantry system isn't to replace a robot. It's more a collaboration with a robot. I think we've done applications ourselves where we've had gantry systems that have had an industrial robot loading the gantry system. The gantry system does the legwork of covering great distances, maybe transferring the product between process lines, and you could even have a second robot that's offloading at the other end.
Absolutely right, and I think what we need to remember with our gantry systems is they will provide the level of precision and accuracy, and even more importantly, repeatable accuracy that you can get on a smaller scale, and that you're certainly not going to get with something that could be described more as an industrial crane. So you've got robots that operate well in a relatively small envelope, and then you've got a gantry system that will absolutely revolutionize the size of that system, but without losing the precision or the accuracy.
Yeah, exactly. And you know, we're seeing in industry today, automation is becoming all the more important. And you know, with those levels of accuracy, repeatability, low carrying capacity, you know, the gantry is really filling an important gap.
Yeah, we think it's probably an increasing part of an industrial market, and quite frankly, our R&D guys have put a lot of time into making our offering as good as it could possibly be. I think we've taken it to the next level. First of all, let's just look at what our R&D guys were trying to achieve. First of all, they wanted to improve the customer experience. What do we mean by that? We will absolutely touch on that in a minute, but customer experience is the amount of time taken from initial interest to the point where they have all the information they need to make a decision to take a project forward. On top of that, we looked at safety in two ways, really. Additional components to our HDS systems that make them safer, and also the level of information of data that we can provide our customers for the certification they need for their machinery or whatever market they're on, and so forth. Yep. We looked at standardizing everything better if we could, in terms of standard rail lengths and standard joint positions, because standardization helps with the two other things that we were trying to achieve. One of those was cost, keeping cost as low as possible for us, for our customer, and also lead times. We supply a more standard product, and lead times are essentially are beneficially lower for that reason. So that's what we set out to do. I think we did it very well. Let's go back up to the first one there, which is the customer experience, Alex, and you're going to talk about the system configurator.
Yeah, and I think, you know, the team here at Hepco really have knocked it out of the park in that respect, and I think it's safe to say we're offering a really unique experience. And you know, the way it's set up is that it will involve one of our highly skilled sales engineers, an internal applications engineer, and more importantly, yourself, the customer, in a online virtual meeting, so whether it's Zoom or Teams, and we'll have a meeting and we'll talk you through your application. So we need to understand the basic parameters such as load, speed, what's your required cycle rate, throughput, etc., required accuracy, deflection, environment. Do we need to use stainless steel rails and bearings, safety?
These are all questions that we ask every day. Anybody comes to us and say, look, what's the best system for my particular application? We ask these questions. They're not rocket science. Most of the time, customers will know what they want. Or more to the point, very often customers will know what they need to achieve. And by hand-holding from day one and walking the customer through with the specific questions, needling out what we need to know, we can go from there to there very quickly to a point where, well, we're offering quite a lot, Alec.
Yeah, so during this online meeting, the applications engineer will be entering this data into our configuration system. And, you know, we take into account things like your factor of safety, and ultimately that will provide us with a lot of outputs in terms of specification of the size of beams we need to use, slides, bearings, etc. So it will generate a full specification, even down to gearboxes. It will take into account, you know, torque, speed requirements, all that sort of thing. So it really goes down to the finest detail in terms of spec of the system. But what it will also do is generate a full sort of package of data relating to the load life capacity of each individual element within the system. So we're going down to bearing level, and we give you basically a load factor for each of those elements. So based on your required life, based on your required factor of safety, we come up with a specification, and we've got all of the data to back that up, which you can use. If you're in UK or Europe, you can use that for machinery directives or your declaration of incorporation, CE marking. But even if you're outside of these areas, you've still got access to that information, which is incredibly valuable.
Well, for critical spares, there are many levels to this.
Absolutely, and you know, to get that level of information, it would take hours, days, if not weeks to the level of detail that we're providing. So it's really quite incredible. The other thing it does on the spot is provide you with a quotation. So you've got a price, and on top of that, it will also provide you with a fully generated 3D CAD model that you can drop into your process line design, for example. So whether you're using SolidWorks, CATIA, etc., we can generate the file to suit you.
So to clarify, fully comprehensive specification and quotation, CAD model, and a full technical report on system life of each component and so forth, right? We think that has definitely taken it to the next level, and we do think that that is absolutely unique. And what that gives us is, from a very, very initial point of interest, we are able to provide the customer with what they need to make a decision and move forward in a very, very short period of time. We're talking a day now instead of weeks. I think you're right with weeks, Alec, and that is a profound improvement. And something that our R&D team have worked very hard on this configuration tool to be able to provide that level of service. And I think we're all
we think it's a game changer.
We do, no, absolutely right. Just quick question there. I thought the payload was 250 kilograms. Transpires that it turns out to be 275, and the speed isn't 900 millimeters per second, but it needs to be 950 millimeters per second because the overall production output needs to be slightly higher. Alec, do we need to start from scratch?
Well, we always love it when the goalposts move. But fortunately, with this new system, the data is saved, and if there are sort of tweaks that need to be made, that can be done relatively quickly. We can repeat the process of generating the quote, the new model, in a very short space of time. So it's incredibly flexible, very powerful, and really sort of, we can customize it to exactly your requirements.
Superb, absolutely superb. Going back to the list that I said before, customer experience was the first on that list. The second was safety, and I think to best discuss or how we've made our system even safer, I think we're better off going through the various product enhancements that our guys have come up with. So if we start at the top of a list of 9, and that would be the X-axis and the ease of assembly of the Y-axis onto the X-axis. Over to you, Alec.
Yeah, so we've listened to feedback, which has all been very useful in developing this product. The configurator is one part of it. That's your sort of pre-sales part, but the optimization doesn't stop there. We've looked at the product and really sort of considered how we can make it as easy for you when it comes to installation and maintenance. So before we were looking at the X-axis, and like you say, if you've got an XYZ system, you'll have two beams running in parallel for your X-axis. One will be V-guides. The opposite side will typically be a flat track roller guide, because it gives you that compliance, means you can set your beam within a few millimeters. It's not critical. and
allows
it
for
will run.
fabrication tolerances, factory tolerance, a whole
Exactly.
host of things as to why that's a good idea.
Yeah, so it's a great idea, but when you're trying to mount that y-axis in place, you have to accurately position it over the V-guide, over the track roller, lifting it all up.
That's not down
3,
here.
4
That's
meters.
usually up there. Yeah.
Might be 6, 7 meters long. Might weigh a few hundred kilograms, and you've got to try and align two ends and guide it over these slides.
It's
so
finicky.
It's a challenge.
Yeah.
So we've looked at that, and now what we can do is basically the X-axis carriages will be mounted to the beams, okay, in advance. So they're already up there. The Y-axis beam assembly now includes some adapter mounting plates, which will allow you to interface with those carriages. And in addition, there's a location pin which drops into a V, which allows you to basically drop the Y-axis in place. That gives it its initial location seating. Put your screws in the mounting brackets, and then you've got a nice little alignment feature which allows you to adjust the tilt on the beam to make sure it's perfectly vertical.
So there you go, you just drop the y-axis down and then you make your finite adjustments, including tilt after that, and that certainly is a considerable improvement on previous methods and other methods that I see out in the marketplace. Okay, I'm also a fan of the new X-axis catches that we've instigated.
Yes, catch it in himself, because effectively what you're doing, we've considered safety is one
They're
of the
another fail-safe.
It's a very much a safety feature, and again, based on feedback, there's been concerns. What happens if one of those never events happen?
Doomsday
Some
scenario.
sort of catastrophic event, such as a forklift truck reversing into one of your nice gantry legs. It knocks everything out. As I said, you've got V-guides one side, flat track roller the other. In that event, there's really nothing to stop that roller side from disengaging, and then all of a sudden your y-axis is succumbing to gravity. Yeah,
no, absolutely right.
So the catch is essentially don't come into contact with the slide. They give you a clearance. It's a bracket which sits over the guide. Should there be a catastrophic failure, then it's just
they will drop
fully
and
supporting,
locate.
and nothing's going to drop to the floor.
Reasonably simple, hugely effective, and again, we're talking about peace of mind there. You're talking about the unforeseeables where they will come into play. Okay, so that protects the system, shall we say, laterally speaking, across one of the axes. Yep. How about system protection in terms of going off the edges of the system, Alec? We've always had, obviously, end of travel buffer systems, but again, we've taken that to the next step now. Yeah,
so again, going back to the configurator, we ask what your factor of safety is, and we basically allow for the y-axis with subsequent z-axis and payload crashing into the end stops, at full speed. And certainly what we don't want to happen is a failure and for stuff to come off the end of the beam. So we've looked at this in a lot of detail, and we've improved it by, instead of mounting these brackets onto the aluminium beam, we're now screwing and mounting into the steel slide, which is obviously much stronger. And those buffer devices themselves, there are 4 options. One is a rubber buffer, and then I think there's about 3 sizes of shock absorber, depending on the payload and speed.
And to clarify, and I think it's worth making the point again, this is factored in on the configurator, where we qualify what the maximum, based on speed and inertia and all that sort of thing, what the maximum impact force might be, then add the safety factor or the level of safety that the customer is looking for, and then automatically the configurator will calculate what the correct end of travel system needs to be adopted for that system. I think that, again, absolutely fantastic. Okay, thank you. let's stay on safety. Let's move to the Z-axis, the good old important Z-axis that's always fighting gravity as well as everything else, okay?
Oh, yes.
Things fail, motors, gearboxes, pinions. These are invariably rack and pinion driven systems. Something like that fails, even a control system, loss of power, things can plummet down. So we've come up with essentially the X-axis brake. Tell us more about that then, Alec.
Yeah, well, I think fair to say, I mean, these failures don't happen often.
Nope.
And it generally involves some sort of external forces
Yes.
that cause these dramatic events. But you're right, you know, if there is a crash and you lose the teeth on the pinion, there's nothing to stop that Z-axis from dropping to the floor. So we've incorporated a new Z-axis brake system. It's a secondary system that runs alongside the Z-axis. It comprises of a ground shaft solution with a sort of taper lock pneumatic brake. And in a power out situation, it will fail safe, so it locks the system up. And equally, if acceleration exceeds a given limit, it will lock and arrest that Z-axis and prevent it from crashing to the floor.
So it's not intelligent, but it will identify that something's in free fall essentially.
And it will grab it. Yeah.
I've got a feeling that's going to be a popular choice going forward, but again, it's one of these things going back to the system configurator where we provide the option at that time. You can go back, change anything at any time, but yeah, it's a question we ask and for very good reason. Staying on the Z-axis, I'll touch on quickly the additional rotary axis that we're now offering, or the end of beam rotary axis, which provides a full 360 degrees of travel when it's required. What that does for us is it provides us the opportunity to provide the customer with the complete mechanical solution. So rather than supplying everything up to but not including something, the full mechanical collusion is within our remits, and we'll touch on some of those other elements as well, but we've got two more things to talk about on the Z-axis. One of them is the telescopic system.
Yes, so one of the challenges that sometimes our customers face is, particularly in older buildings, head height can be a bit lower, low ceilings, and in that situation, the telescopic axis can come in to save the day. It has a lower overall head height, but can still achieve a decent amount of vertical travel.
Absolutely right.
It's a multi-stage construction.
Yeah. Good stuff. Not always required, but very often required. And I think we've probably both been in situations where a telescopic axis is definitely required.
Sometimes it just saves the day. Yeah.
Yes, it does. One other thing on Z-axis, DLS, one of our most proven and popular ranges over the years. A long time ago, we brought out the cantilever DLS option, where the carriage and the motor are static, and it's the beam that's the moving element. And the advantage of that is when the beam moves out of the way, there's nothing there. You're leaving a complete space. And again, the perception with the DLS3 a DLS3C, was great, but we could do more capacity. So what have we done, Alec?
Yeah, I mean, the DLS3C is a great concept, as you mentioned. If it ain't broke, don't fix it. So what we did is we've taken it to the next level. We've incorporated that design within the framework of our larger DLS5. So you've got DLS5C. Again, it's a belt-driven system, static carriage and drive system with a dynamic beam. And that allows us to move from, say, 4 or 5 kilograms that the DLS3C is capable of lifting, up to about 20 kilograms, while still maintaining good dynamics. We could potentially go a bit heavier if we slow things down a little bit. Well,
we know that everything depends on speed and even more importantly the accelerations, but as a general rule then we're talking about probably a situation where we're increasing the capacity by a factor of 4 compared to the DLS3. In terms of heavy duty and heavy duty gantry systems, one might regard that as being able to offer high speed, but maybe some of those lighter duty systems, but definitely relevant, and also as a standalone product, something to remember in the future. Last but not least, and again, this will go back to questions asked on the configurator, we have standard cable chain options, and of course, we have standard legs to hold the whole thing up with. Alex.
Yeah, I mean, these are all part of sort of quality of life additions that we've included in the range. The legs can be configured in terms of their height. They're sized according to your deflection requirements.
Yes.
And they include an adjustment plate as well, so we can adjust that beam height and level.
The X-axis beams.
The X-axis beam. So it's really gives you that extra option. Like you say, cable chains, you've got to manage your cables somehow. So we need to know the number of cables, the sizes, and that can all be sized and included. There are other sorts of additions. Gearboxes can be supplied. Going back to quality of life changes, the lubrication pinions are now fully removable. We've also got automatic lubrication options. So yeah, it really does give a complete mechanical solution, as you say, David.
Fantastic. Alec, I think that's about 30 minutes. We could, I guess, easily talk about this subject for 2 hours, but we're out of time. I'm hoping that what we've managed to cover is the customer experience, again, the safety, the cost savings and the time savings that we set out to do. We will absolutely look forward to answering any questions that you guys have for us. Thank you for your time so far.
Okay, thank you. Welcome back, and here we are, David and I, prepared to do our very best to take your questions. If you haven't dropped a question in yet, please do so in the Q&A module, either the bottom or top of your screen, and we shall try and get through these questions as fast as possible. I can see there's a few stacking up already, David.
Go for it.
So we'll kick off. First question, I'll put this across to you. What's the maximum payload that HDS can handle?
It's a good question. There are a number of factors that go into dictating what that payload can be for any given system. Factors include the speed of the system, or even more importantly, the acceleration and the offsets as to that apply, especially when the system is dynamic, when the system is being moved. So it's not. You can't pluck a figure from the air and say, look, that's the maximum payload. What we can say is it's determined, those factors determine the maximum payload, and in general terms, we can be looking at masses, shall we say, 400, 500 kilograms in the right circumstances.
Yeah, and I think just to add to that, it's worth bearing in mind when we talk about those payloads, that has to include your tooling as well. So whether you've got a gripper or some sort of mechanism, product handling, it falls within that basis.
Absolutely right. Yeah.
Okay, next question from Phil. On large gantry systems, how can you assist on working out the structural support required, i.e. the steel work? Great question. Thanks, Phil. So yeah, with regards to the steel work, the support legs, which we've given you a sort of glimpse of today, that is the specification of those is included within our specification software and system. So it's all done within the taking into account the machinery directive when we specify those. So when we look at the required deflection or rigidity that you will have given us during our sort of consultative meeting, and that will determine the size of the leg, and of course the height is configurable to a degree, and of course the spacing of the legs when you're looking at along the x-axis we'll determine that based on the deflection that's required.
Good point. Yeah.
Anything else to add on that, David?
No, I think you've done it all.
Perfect. Okay, right. Next question from Matthew. What's the general turnaround of an assembly with costing? So I guess that's really sort of looking at the the process of our start of our meeting. We run through the whole process with you in terms of the application data and then getting to the stage of providing you with an assembly CAD model and costing.
Oh, pretty much. It's instantaneous, isn't it? Once we've had that consultation with you, that online consultation with the sales engineer and our tech guys, you give us the information we need, and you get everything that you need in terms of CAD drawing, quotation, and so forth. So I think we can safely say, 24 hours, really.
Yeah, I mean, I would say, the actual, we can give you a budgetary price there and then at the end of the meeting. That will be determined once we've, providing we've gone through all the parameters and got that detail from you. I would suggest these meetings would take, maybe an hour, 2 hours maximum. It's probably on the high side. Yeah. And in terms of the CAD model, that can be done in real time. While we've got you there on the meeting or shortly afterwards, and to generate the CAD model, it takes about 10 minutes. SolidWorks, which we use, has to put these things together. It takes a bit of time to generate, but it's, in the big scheme of things, it's really not long at all. We were looking at, this would have been something that would have taken hours, days, weeks.
Well, I make the point, this is something we were trying to do. This was something we set out to achieve, to get this information faster to the people that need it in good time. And that's what we have achieved.
Yeah. Okay, next question. Is the Gantry configurator available to us, or is it configured by your engineers? The configurator is run by the Hepco applications team here, purely because there is a lot of data which we need to consider and put into that system. So we sort of walk you through the process, but the guys here at Hepco will drive the configurator, and that will provide the outputs that you need.
Yes, yeah.
Okay, another question. What is the general clean room class? So in terms of clean room, it doesn't have a specific classification, but certainly we have seen these systems used in sort of the lower end of the clean room grade. So, maybe a class 8, class 9, but that's really down to you, the customer, to make sure it complies with those standards.
It's a question we get asked quite a lot, actually, across our complete product range, and this applies in exactly the same way. Like you've said, we do not have any specific clean room accreditation. However, we've got plenty of stuff that's operating successfully in clean rooms, and that would apply to HDS as well. Just essentially tell us what your clean room classification is, and we'll let you know what experiences we have with that.
Yeah, and just to add, the HGS Gantry components, in terms of the bearings and track, they are available in stainless steel materials as well. So when it comes to clean rooms, obviously that can be a factor.
Yes.
Okay, right, next question, David. We have, what type of speeds are available with HGS?
Well, this kind of goes back to the question about maximum payload, because again, maximum speed will be determined by other factors. In terms of heavy duty gantry systems, we probably look off to start with as standard at anything from 250 millimeters a second up to a meter a second. But under the correct circumstances, under the right circumstances, we can certainly go faster than that. And if I was to put a figure on maximum or high speed at the moment, I would say 2.5 meters per second.
Yeah, and obviously we have to observe Newton's laws in all of these things.
A lot of inertia.
We can't get around that, but generally the faster you go, we have to limit the payload that you might be able to carry in those circumstances. Okay, let's move on. Is there a limit for the length of X and Y axes?
Well, what do you think? I'd say there is no limit to the length of an X-axis, because again, that's supported. in intervals to suit the level of the weight and the level of permissible deflection, so that's not a problem at all. That can theoretically go on forever. The y-axis is a different situation, because that of course is a simply supported, where it's supported on each of the axes, but the y-axis is unsupported in itself. And off of the y-axis, of course, you have the z-axis. So there is a limitation to the y-axis. Where would you put that, Alec?
Yes, it really depends on the beam length, but fundamentally we cannot have an unsupported beam join. Okay,
no,
so with the x-axis, we can join these beams together. We overlap the slide join and the beam join, but importantly, we must have a support leg at the beam join position. That stops the deflection of the join, because effectively you haven't got solid material, and you can throw as many connections and fixings at it as you like.
Yes,
but you definitely need a support leg in that position.
By that rationale, then we're talking maybe around about the 4 meter.
So beam lengths, we've got standard beams up to 6 meters, and some in 8 meters in some cases. But I think 6 meters is probably the realistic limit on the y-axis.
Good question. Yeah.
Okay. Right. Let me get on to the next one. Jacob, great webinar. Will you update the HDS2 catalog on your website? Okay, Jacob, the HGS product is a sort of separate extension, shall we say, of heavy duty or HDS2. So HDS2 remains as a product. That will still be very much available. So if you customers want to design something using our heavy duty range in a component based form, then HDS2 still very much applies.
It does.
Okay.
Yeah.
And then if you want a fully sort of tailored system solution, Gantry solution, that's when you start looking at using the HGS.
Absolutely right. They're completely different product. Well, they're not. HGS uses standard componentry from HDS2, of course, but important not to confuse them as being the same entity. They are different product ranges.
Okay. Yeah, thank you. Next question up. What is the positioning accuracy of the system? Okay, this is good question, and it's really based on partly down to the drives and controls that you're using.
Yes.
So we basically go up to the gearbox. We can do AC motors, but generally, if you're looking for high accuracy, repeatability, then it would generally be a servo drive. Yeah. And realistically, with these systems, because it's a rack drive, you'd probably be looking at plus or minus 0.5 millimeter.
I was going to say,
I would say it's going to be in that sort of ballpark figure.
Yeah, and in heavy duty terms, greater accuracies than that are not normally required. Precision with heaviness doesn't always necessarily sort of like carry through. So yeah, I'd say plus or minus 0.5.
Yeah, okay. Right, fantastic. Next question from Shavolks. Thank you, Shavolks. How can the beams be fixed to the support? Okay, so we include, this is all included as part of the HGS offering, and there are adjustable plates which are installed on the top of the support legs. Okay, so that allows you, it includes all the fixings onto the beam. Okay, you can see the beam's got T-slots, so there's bracketry that connects to that, and then this adjustable plate allows you to level and align it.
Yeah, I think there's 5 mm of height adjustment in that plate as well.
Yeah. Okay, another question from Jacob. Do you consider some of the updates with hardened teeth range of the HSS Rails? Okay, so Jacob, you're talking about the teeth on the rack drives. Okay, so fundamentally, with the x-axis, we generally don't need to use a hardened rack, but certainly with the vertical axes, so your z-axis, then we will use a hardened rack in that situation. It's either mod 3 or we have our ESR, which is a large mod 5 rack, which is hardened, and that gives us sort of the maximum sort of lifting capacity. We can also, if we got particularly heavy loads, we can also come up with sort of double ZAxis type configurations as well. So that increases the lifting capacity.
That's a good point, yeah.
Okay, next question. Do you provide the motors, controllers and energy chains?
Well, we can supply the cable chains, we do. That's available as a complete package as required. We can supply the gearboxes and we can supply AC motors, but beyond that, the controls and any other form of more intelligent motor such as servers, etc., that's not our expertise. That's where we finish and where customers essentially interface with their own selections.
Yeah, so just to let you know, obviously with the configuration tool, that will provide your motor and controller supplier with all the required sort of driving speeds and torques that will require. The gearbox interface itself can be figured to match your motor, your servo motor. So, you know, you generally work with a controls and drives integrator, and you know, they essentially get all the information they need to put this together and make it work.
Yeah.
Okay, last couple of questions, David. How much vertical space is saved with the ZAxis Telescopic Axis?
Okay, we thought this might be coming, didn't we?
We did,
and
yeah.
we've worked out an example.
Yeah. So there is an example we can give, and essentially, if you're looking at about 2.8 meters of travel, then the height saving on the telescopic unit is about 950 millimeters compared to a standard sort of fixed beam Z-axis type solution. So
that suggests a third, doesn't it? But obviously, as you go smaller, you'll not, because there are certain non-variables within that system, and so as you go smaller, that as a percentage, you can expect that to reduce. But I think that's a fair indicator for something of like you say, a 2.8 stroke.
Yeah, perfect. Thank you. Right. Okay. Moving on. How critical is lubrication, and what needs to be lubricated?
Lubrication is important. We've said before about how forgiving a V system is in terms of maintenance. If somebody forgets or it's not done, a system will run dry. And lubrication, a very, very small amount of lubrication is enough to keep a system lubricated. However, these are, with the Gantry system, it is important to keep the racks lubricated, and also the tracks, the V system, and to a lesser extent the track rollers, the flat tracks on the other side as well. So I would say it's reasonably, it is important to lubricate. It's less of a pressure to lubricate, but please don't underestimate what proper lubrication will give you in terms of longevity of life.
Absolutely, yeah. And talking of life, next question that's come in, what do you mean by system life? What needs replacing at that point? Okay, so we give you what we call a service life. So once we've gone through the configuration process, as we've talked about quite a lot in this presentation, we'll provide you with a service life for that system. And that is specifically looking at the life of the bearing element. Okay, so we anticipate at the end of life of the bearing, the internals of the bearing become worn slightly. This may be evident by increased clearances within the bearing. The system might start running a little bit noisier, but crucially, it won't catastrophically fail. Okay, these things will continue to run on, so you've got a window of opportunity to change those. There is also an adjustment period as well. So it can be that you simply need to readjust the bearings. Okay, you've got the eccentric bearing feature, take up the clearance, and then it goes on again.
Just adding on that though, this goes back to lubrication actually. If the system is lubricated properly, then the bearings, theoretically, the bearings are the only element that will need to be replaced. If the system is lubricated properly, you should not see, and it's obviously used within the parameters of the specification as was intended, you shouldn't specifically see wear on the rails themselves. And so, yeah, service life, replace the bearings. Going back to the previous question on lubrication, you save yourself money in the longer term with not having to replace the tracks.
Great. Okay, David. Well, it looks like we've pretty much come to a close there. We've wrapped up. Thank you very much for your questions. Really appreciate that. Yeah. Thank you very much once again for joining us. Really appreciate your participation. Keep an eye open on our social media and our website.
Absolutely right. Looking forward to next time already.